Hello, algebra, honors algebra, and algebra light students. This video is appropriate for all of my students because you all have a test on Tuesday, and this topic will be on all three. It's going to be a quick review of the real number system. So really quick, we're going to talk about what does N stand for. N was the natural, where are you? There we go, natural numbers, right? And how do the natural numbers begin? Well, the natural numbers begin with 1, 2, 3, and they go on forever, right? So I might write that basic definition there, right? Some examples, as some of you say. There are no decimals, no fractions. All right, and then the next number system, as you recall, was the whole numbers. And the whole numbers include all of the natural numbers, but they also had, what is it? I know Charlie knows. That's right, Charlie. They include 0. Way to go. I'm proud of you. All right, here we go. 1, 2, 3, on forever. Still no decimals, no fractions. That is supposed to be a 3 there. I have troubles making 3 with my airliner pen. Sorry about that. Okay, the next number system. I'll bet you that Lucas knows. Lucas knows the next number system are the integers. The integers. And the integers are just like the wholes, but they also include the negatives of the wholes. So the integers have no beginning, and they have no end. They include all the whole numbers, that's a positive one, sorry, and the negatives of the whole. Still, no decimals, no fractions. Now be careful, a lot of kids think, uh-oh, if I see a negative, that's an integer. Nope, it's got to be a negative whole number to be an integer, not just a negative. Okay, so where do the fractions come in? Well, the fractions come in to the rational numbers. Right? The rational numbers. And the rational numbers include all of the integers. Yes, they do. Believe it or not, they include all of the integers, but they also include all fractions. If a number can be written as a fraction, it's rational, all fractions. Now, there are two types of decimals that can be written as fractions. Two types of decimals, right? Two types of decimals. One is the terminating decimals, right? Terminating, I'm going to abbreviate that. And 2 is the repeating decimals. As you ask my algebra light kids, they can write a repeating decimal as a fraction. If you don't know how, go ask them, they'll teach you. All right, a repeating decimal. All right, so we've got terminating and repeating decimals. So if it's a fraction, if it's a decimal that terminates, if it's a decimal that repeats, if it's a whole number, if it's an integer, if it's natural, then those are all rational. So that would mean like things like the square root of 9 are rational, right? Because the square root of 9 is 3. 3 is a natural number. If I'm 3, aren't I inside the natural circle or oval? I'm inside the whole oval. I'm here, you can't see me yet, but I'm right here in the integer oval, and I'm also inside the rational oval. Okay, now there's that special group of decimals that never terminate, never repeat. Now, it's not good enough to just say it goes on forever. Not good enough. Oh, no, dear. I thought we lost my computer. All right. These are the irrationals. And these are the decimals that never terminate. They never terminate. Decimals that never terminate. Did I mention they don't terminate? And it also means they never repeat. Doesn't mean the digits don't repeat, there's no repetition to the pattern. Okay. So those are the irrationals. The most famous is pi, but it also includes things like the square root of 5 or the square root of 17. There's a number under a square root that's not a perfect square. It's going to be irrational, guaranteed. Altogether, these make up the real number systems. I can't find my mouse. Okay. So let me put the R in there. Altogether, these are the real number systems. Now, I'd love for you to pause the video and see if you can determine what number systems these 7 numbers belong to. Go ahead and pause the video, and then we can see our answers. Don't unpause it until you're ready to see. Okay, if you haven't paused the video and done this on paper yet, you need to really do that. Here come my solutions, last chance. Okay, I've got the square root of 18. 18 is not a perfect square. That means there's no square root of 18. There's only approximations of it. So that is an irrational number. Now, all the numbers we deal with in algebra are going to be real numbers. Okay, this 2 and 61 hundredths, but the 1 repeats. That's a repeating decimal. I said the word repeat, which means it's going to be rational and real, right? 3 and 1400ths. I hope I didn't fool you on this one. 3 and 1400ths is not pi. It's a terminating decimal. So therefore it's rational and it's real. All right, square root of 144. Oh, I know that. That's 12. 12 is a natural number. It's also a whole number. It's an integer number, which doesn't sound right. It's a rational number. And of course, it's a real number. Did you notice I skipped the irrationals? Yeah, I did. You can't have a number that's rational and irrational at the same time. Okay, so negative 3/4. Hope I didn't fool you. It's rational. It's not an integer because it's not a whole number. Integers only include the wholes and the negatives of the wholes. It's also real. All right, negative 7 is an integer number. A rational number. Uh-oh, dear, dear, dear. And last but not least, a real number. Okay, finally I have 24/6. Well, I like to simplify fractions as much as possible. 24/6 is a natural number. It's a whole number. It's an integer number. Yes, it is. Yes, 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 it is. It's a rational number. My airliner is giving me fits. Okay, and finally, it's a real number because 24/6 is the same as 4. Okay, now one more thing I want to do. We're going to play everybody's favorite game show, rational or irrational. You see I've divided the board up into two sides, and you're going to take these numbers down here and decide if they are rational or if they are irrational. So I'd like you to pause the pause the video, and we will take a minute, then we'll unpause it, and you can see if I agree with your answers. All right, here we go. If you haven't paused the video, now's the time. Pause it, pause it. Are you listening to me? Pause it. Okay, here we go. Here come my solution. Square root of 1. I know the square root of 1 is 1. Why? Because 1 times 1 is 1. Therefore, 1 is rational. The square root of 1 is rational. Square root of 2. I don't know the square root of 2. I know it's around 1 in 4100, somewhere around there. 2 doesn't have a square root. 2 is not a perfect square. This must be an irrational number. 3. 3. Did I fool you? Some of you would just go, rational or irrational. No. Look, 3. You can count your 3 cookies, right? It's a natural number, which forces it to be rational. All right, 6.614 ... Looks like this goes on forever. I don't see a repeating symbol. A decimal that goes on forever without repeating is kind of like pi. This must be irrational. This funny looking thing here is a 0. Is 0 rational or irrational? Rational or irrational? It's like we're at the eye doctor, you know, number 1, number 2, number 1, number 2. It's rational. It's a whole number. Whole numbers are rational. Okay, 2 and 4500ths is a decimal that terminates, it ends, it got cut off. Decimals that end, decimals that terminate, rational. Okay, negative 12/7. Hey, wait a minute. I remember Mr. Laurence saying something about all fractions are rational. There we go. And finally, pi. Pi. Well, pi is the most famous of the irrational numbers. There we go. That's it for the video. I hope it helps you. There will be some more on some other things. All right, Mr. Laurence signing off. Have a good night, everybody.